Hello, welcome to Unit 3, Lesson 2 with Professor Blackman. Today we'll be solving systems of equation by substitution. So we're going to start out by just go ahead and looking at systems of equations and then solving them. And then we're going to have a couple problems they're word problems, so we need to apply substitution after creating the systems ourselves. We have special cases that may happen. If you ever get an equation that is false, let's say you have something like 0 equals 4, that's never true. So you'll get, we would say that's no solution. And then if you ever get something where it's like 0 equals 0 or 6 equals 6 or whatever, but the equation is true, that is when we would say it's infinitely many solutions. All right, let's go ahead and get started. All right, so here we're going to do substitution. So we're going to take all of this and make it our x. So 2y plus our new x, which is 3y minus 3, needs to equal 9. Nothing in front of this parentheses, so this is 5y minus 3 equals 9. 5y 5y adding 3 to both sides, 5y equals 12. So then y equals 12 fifths. And then we know x equals 3y minus 3. So then x equals 3 times 12 fifths minus 3. But I'm going to go ahead and change 3 to 15 over 5. 15 over 5 is 3. So that's 36 over 5 minus 15 over 5, which equals 21 over 5. Now, this is a ordered pair with xy, so we would put that as 21 over 5, 12 over 5. Now, since we use the second equation to get our x here, when we go to check, we really just need to check in that first equation. So let's go ahead and check. So 2y, which is 12 fifths, plus x, which is 21 fifths, needs to equal our 9. So that's 24 over 5 plus 21 over 5 needs to equal 9. 24 and 21 is 45 over 5, which in fact is 9. So that is our solution. All right, let's look at this next one. So all of this is our x. So we're going to plug that in. So that's 3 times x, which is now 8 minus 4y, plus 5y equals 3. Distribute that, and we get 24 minus 12y plus 5y equals 3. Subtract this 24 from both sides, and negative 12 plus 5y gives you negative 7y equals negative 21. Divide by your coefficient of negative 7, and we get y equals 3. So again, this is an ordered pair, and we know that y here is 3. Let's go ahead and now plug that in to x equals 8 minus 4y, which is now 3. And we get 8 minus 12, which is a negative 4. And so that is what x is. Now let's check that. Checking that second equation, because we use the first equation more. So 3 times negative 4 plus 5 times 3, which is our y, equals 3. So negative 12 plus 15 equals 3. And 3 does equal 3. So that is correct. Let's go ahead and look at another one. All right, so let's take this y and plug in there. So we have 9x minus 2 times y, which is now 7x plus 8, needs to equal negative 6. So 9x, distribute that 2, negative 14x minus 16 equals negative 6. Add 16 to both sides and combine your like terms. You get negative 5x equals a positive 10. Divide by your coefficient, and x equals negative 2. We can take that second equation, which says y equals 7 times x, which we now define x as negative 2, plus 8. And so 7 and negative 2 is negative 14, plus 8, which is negative 6. So we have the second part of our ordered pair, which is negative 6, and our first part was negative 2. Let's check that. Since we plugged into the second equation here, we can check using the first equation. 9 times negative 2 minus 2 times negative 6 needs to equal negative 6. 9 negative 2 is negative 18, plus 12 needs to equal negative 6. That does in fact equal negative 6, so we know that this is correct. All right, let's look at the next one. So take all of this and plug in for y. That gives us 2x minus 3 minus 2x equals 1. 2x minus 2x would cancel out, so we get negative 3 equals 1. So this is one of those special cases which isn't true, so we would say no solution. All right, let's look at another example. All right, so here's our first application problem. So what we first need to do is set up the system of equations, and then after we get that, then we can solve. All right, it says an ancient rectangular court has a perimeter of 60 meters. So 2 length plus 2 width equals 60. Okay, so that's what we got from the rectangular perimeter. All right. Now we are also told the length of the court is 5 times the width. So the length is equal to 5 times the width. And so now we have our two equations that are set up. We can take all of this of our L and plug in right there. So we have 2 times L, which is now 5W, plus 2W equals 60. 2 times 5 would be 10, plus 2 would be 12. So 12W equals 60. So then W equals 5. And we know the length is equal to 5 times the width. So that would equal 25. And we can quickly draw a rectangle. And we can say that this is 25 meters, 25 meters. This is 5 meters, and this is 5 meters. And you can see 5 and 25 is 30, 5 and 25 is 30. This perimeter has a perimeter of 60. So we have our length, meters, and our width is 5 meters. There. All right, let's look at our next application. All right, so we are told a team is awarded 2 points when they win and 1 point when they tie. A team won the championship with 60 points. So 2 points for a win plus 1 point for a tie. Now, I wouldn't typically put that 1 here, but we are writing it. And they had a total of 60 points. So these are all their points. The next part tells us they won 9 more games than they tied. They won 9 more than they tied. So winning is equal to tie plus 9. So if they tie 1, then they win 9 more. So 1 tie is 10 wins. But we've got to solve this to figure that out. So let's take this t plus 9 and plug in for the w. So 2 times w, which w is now t plus 9, plus t needs to equal 60. Distribute that 2, we get 2t plus 18 plus t equals 60. Subtract 18 for both sides, and we get 2t and t giving us 3t equals 42. Divide both sides by 3, and t equals 14. And so now that we have the ties, we can calculate the wins because it's 14 plus 9, which is 23. So there are 23 wins and 14 ties, which, remember, wins are worth 2 points, so that would give them 46 points. And 14 ties are worth 1 point each. And if you add that together, you get their 60 total points, which is what we needed. So our answer is correct. It's always a good idea to check your answers to make sure you work your problems correctly. That's all I have for you today. Happy studying.